This video is a continuation of the functions notebook and is going to discuss recursion in Python.
Now, while this may not typically be included in introductory material, it's important enough that you should be aware of what it is and that Python supports it. So, recursion is a tool that can be used to solve a problem where a solution depends on the solution to smaller instances of the same problem. This can be realized by a function directly or indirectly calling itself. Now, if a function simply called itself without any other code, then this would result in an infinite number of function calls that would ultimately cause the interpreter to raise an exception. And so to prevent this, recursive functions employ what's called base cases, which are instances of the problem that can be solved without recursion. Effectively, base cases stop the recursion and allow the function calls to unwind. So let's look at an example of this. To compute n factorial, we multiply n times n minus 1 times n minus 2 and so on until we get to 1. And this can be realized by a simple for loop. So let's write a function, fact1, that's going to take a parameter n and then compute n factorial. So this function will start at 1. So we're going to say result equals 1. And then it's going to multiply result by each consecutive integer until we get to n. So we're going to write a for loop that iterates over the range 1 to n plus 1, since we want to include the value n. And it's just going to multiply the result by I. And after the for loop exits, we return result. Now, if we call the function, say with the value 6 here, we compute 6 factorial, we get 720 as output. Now, I chose this particular problem as an example because n factorial also has a recursive formulation. N factorial is equal to n times n minus 1 factorial, where n minus 1 factorial is a smaller problem than n factorial. Also, we know that for 0 or 1, the factorial is 1, and that we're only going to consider positive integers. So our base case for this can simply return 1 if the input to the function is 1 or less. So to write our recursive function, we're going to call our function fact2. Again, it takes n as an argument. And we begin with our base case. So it's important to place your base cases prior to any recursion in your functions so that they have a chance to stop the recursion before it happens. So in this case, our base case is if n is less than or equal to 1, return 1. And that's because we're going to assume here that all our inputs are positive integers, and we know that 0 and 1 factorial have the value 1. And now for the recursive step, we're simply going to return n times the solution of the smaller problem, which is going to be fact2 for n minus 1. And that's it. This is our recursive function computing n factorial. And if we call fact2 with 6 again, you see that we get the same result as above. So as another example, I've given you here a recursive implementation of our Fibonacci function that we used earlier. The parameter here is a little different than before, but I'm going to let you go through this to see how it compares to the previous implementation. And you can see the output of this new implementation, fib3, as well as the previous fib2 in the next block. Also, at the end of the notebook here, I've given you links to the documentation as well as the official Python tutorial on several of the more advanced topics concerning functions.